Hello everyone. So today we will be discussing or continuing our discussion on grammar and language. So now in today's video we will be discussing about how we can obtain the language which is recognized by the grammar, and mostly we will be talking about the context-free grammar. So we'll see if a context-free grammar is given, we will try to write down the language it accepts. So let us take up the first question. Now, as we all know that the uh, grammar consists of a set of non-terminals. So S is the non-terminal. Set of terminals. This language or this grammar can only accept a single terminal A. This P is the set of production rules. So there are two production rules given in the grammar. One is S tends to AS, the other one is S tends to A. So now either I can expand S using this rule or the second rule. And since there is only one non-terminal, it is the starting symbol. Now let us first see how we can do the derivation of the strings. So S is my starting non-terminal. So from here, if I expand it using the rule S tends to A, this is the terminal here. So we cannot do further expansion, and this is the string accepted by this language. So let us see what all strings are accepted by this language. So first we obtain as A. Now this is done. Now let us expand S using the other option. So this is S gives me AS. Now this A is a terminal which cannot be expanded further. However, this S can be expanded using again either of these two rules. Let us select the expansion using A. Now this has reached to the terminal. We cannot do the expansion further. So the string accepted is AA. Now again, let us try out a different option for S here. Okay, so let us see if instead of S, if I would have selected AS here. So, and then for this S again A. So this time the string would be 3 times A. Now if you consider again instead of this A, we could have done the expansion using the other rule which is AS. And if you see this AS is going on continuously and keeping on adding one A to the uh, previous string. So if we see this in terms of recursion, so what are we doing? We are having the non-terminal here. So in terms of grammar, whatever is on the left hand side, if that is repeating on the right hand side, it means that we are creating a recursion, which means that A is getting repeated because of this S being present on the right hand side. Okay, so what are we doing? We are increasing the number of A's, and that is what this grammar is telling us. So here are the few strings which are accepted. So if I have to write it in the form of language, I will write it as L equals. Now, how many number of A's can I accept? I can accept A, but how many? We can write it in a generalized form, say A raised to n, such that n is greater than equal to 1. So this says that I need at least one A because it is greater than equal to 1, and then I can have any number of A's specified by this n. So this first question, the given production rule or the given grammar can be represented using this language, that is a raised to n, a coming n number of times with at least one occurrence of a. Now let us have a look at another question. So this is the next question, wherein the non-terminals are SA, terminals are A and B. So these are the production rules, and S is the starting state. So this means that we'll start the expansion from S. And again, we'll now look at a few valid strings and then form the language which is accepted by this grammar. So for S, I have two options. Either we can expand using AA, or we can directly expand it with epsilon, that is a null string. So null is accepted here. So this is the first string. Then let us expand using AA, and A can be further expanded using this rule of BS. And now in the next step, let us make this S as epsilon. So epsilon means nothing. We are just terminating this non-terminal ahead, and the string which is generated here is AB. So the first minimum string that this language or this grammar generates is AB. Now let us have a look at the next option here. Okay, so S tends to, this does not have another option. We have another option for S. Now, instead of using epsilon, we again say expand it using AA. And then this A can further be expanded with BS, and this S becomes epsilon again. So now the string which is accepted is ABAB. And then instead of this S, if I again make it AA and do the expansion, the next string that would be accepted is AB. So here the recursion is happening by increasing the A's and B's together. So the language which is generated is AB n number of times, such that how many number of n's can we have? We can have greater than or equal to 0. Now why 0? Whenever we can allow acceptance of epsilon, we mean that this is 0, which means that A or B coming how many number of times? 0 times. So this is not 1, this is basically AB, the repetition of AB coming 0 number of times, which is nothing but epsilon. And if n becomes 1, this will be AB raised to 1, that is A coming once and B coming once. So this is the language for the given grammar. Now looking at the next question, here we have the minimum string as epsilon. And then let us try to expand it using ASB. Now, as I have told you in the previous question that this S, so if I have the same non-terminal repeating on the right hand side, it means that we are creating recursion. So recursion is created for what? A and BB. And at this point, there is a recursion. So I will be able to add A, B, B every time at the center. So that is called as creating recursion here by inserting. So again, if we see here, we already have 4 times B. If I now add S or expand S, it will be A double B again. So I am able to do the expansion at the center because of this S here. So let us see, this can be made epsilon initially. So this would be accepting A, B, B. Now, instead of making this epsilon, if we expand it again using A, S, double B, this is creating a recursion and we have double A 4 times B. So this is my next string which is getting accepted. And then I make this epsilon. So we have AA and 4 times B. Again, instead of this epsilon, if we take another option here, so the next option is again ASBB. Making this epsilon, here is the string 3 times A and 6 times B. So now the language is very much clear that what is happening for 1A, we are always having two B's which are getting added. So what we can do here is we can say that this is A raised to N and B is say B raised to M. So first we have A's followed by some number of B's and then we specify what is the relationship between this N and M. So we know that for one single A we need two B. So M is basically 2 times N. And since we are allowing epsilon, we say that this N is greater than equal to 0. So if N or A becomes 0, we will not have B. But as soon as we have a single A, we'll have two B's corresponding to it added every time. So this is the language that will be generated. Okay, so let us take up another example here. One slight mistake here. This is 3 terminals and here we do not have epsilon. Okay, so S can give me A, B, B, and this B can be expanded using either of the rule. Let us expand it using epsilon. So if we expand it using epsilon, we have AB as the minimum accepted string. After this, we can try another option for B, which is BC. And now this B can again be made epsilon. So we have AB and C coming at the center. Again, instead of this B, if we expand it again with BC, so this B made epsilon again, we are having 2C at the center. So if you see this B here has created a recursion of C's at the center. So we can add any number of C in the center of A and B. And now if you see this A and B are fixed or they can just be one in number. So we have A and B as fixed uh, input characters, but the center C can be N, where this N value can go maybe greater than or equal to 0 because not having C is allowed in AB. Otherwise, this C can be anything 1, 2, 3, 4, and always it will be coming at the center. So this is about converting or finding the language from the given context-free grammar. Thank you and happy learning.